Hey guys, we're on Unit 7, and this is day 10, and we're going to work with some more similar triangles today and practice the difference between having to separate your triangles to set up the proportion, mid-segment, where you know what the scale factor is so you can find your missing side, and side splitter, where they give you the parallel line, and it splits the two sides that it connects proportionally. Okay, so we'll make sure that we practice today. So in our warm-up, we have two triangles and they say that they are similar. So I'm going to go ahead and draw one triangle and we'll call it RST. And because it's similar, I don't want to draw it identical to triangle RST, but I want to draw it the same shape as I drew that triangle, but maybe bigger or smaller. So I'm going to go smaller. And we'll call it triangle ABC, and I have to label it the same way. So wherever I put R, it matches up with A, so they have to go in corresponding spots. They're going to tell me that angle A is x squared minus 8x, and that angle C is 4x minus 5, and that angle R is 5x plus 30. And they want me to find the measure of angle C. So before I find the measure of angle C, I have to solve for x. And based on what they're giving me here, they gave me two angles that correspond to each other. And I know that angles, even though the triangles are different shapes, that the angles have to have the same measure if they're similar. And so I know that angle R has to be congruent or equal to angle A. So I'm going to take the 5x plus 30 for angle R and set it equal to angle A, which is x squared minus 8x. And I also know that that squared term means I'm going to have two answers, and that I'm not going to get the two answers unless I do something called factoring, and I can't factor unless I'm equal to 0. So I'm going to go ahead and subtract my 5x and bring it this way because I want to keep my x squared positive. I'm also going to go ahead and take my 30 and subtract it on over as well. That way these terms are gone, and I'll have everything on one side and 0 on the other side. So I have an x squared. Negative 8x minus 5x is negative 13x, and then minus 30. And I have nothing on the other side, so I'm going to put my equal 0 on this side. All right, that's a nice easy trinomial. So when we set up our x box, remember your multiply number is the last number, and it's at the top, and our add number is the middle number at the bottom. And now I have to find two sets of numbers that do the job. And the first ones I think of is, let's see, negative 15 and 2. However, at the same time, I'm also have in the back of my mind negative 10 and negative 3. All right, so looking at the numbers negative 10 and negative 3, that gives me the negative 13 here. But if I multiply them, I get a positive 30, and that's not what's at the top of my X box. And so I don't think that those are the right numbers. But if I look at negative 15 and 2, they also give me negative 13. But when I multiply them, they give me the negative 30. And that's how I know those are the correct numbers. They work in both. All right, and so we're going to go ahead and do our easy trinomial factoring where we go right to our factors. One will be x minus 15, and the other one will be x plus 2. And we are equal to 0. And when I do my t-chart, on this side, x is going to come out to be positive 15. And on this side, I'm almost out of room, but x is going to come out to equal negative 2. All right, with two answers is fine in math, except in geometry, when our problem comes with a picture of angles, and I know angles can't have a negative measure or a 0 measure, we're going to have to plug in and see which one goes away. We always kind of assume that it's the negative one that goes away. However, we should never assume, we should actually prove it, that it's going to go away. So I'm going to go ahead and plug in my negative 2 into angle C, and I end up with negative 8 minus 5, which is a negative 13-degree angle. And now I have proof to go ahead and reject that because we know we can't have negative angles. Okay, and so we'll keep our 15 as our value of x. And now we're going to go back and we'll plug in 15 instead of negative 2 into angle C. And so we end up with 4 times 15 minus 5, okay, which is 60, minus 5, which is 55 degrees for angle C. And now we can box that up. Okay. All right. So Again, the warm-up was testing us to make sure that we know that the angles stay the same, even though the triangles are different sizes. If the triangles are similar, all angles are congruent. All right. In our first picture here, we have triangle ABC. It says find X, given that DE is parallel to BC. So because these lines are parallel, okay, they didn't mention midpoints. And I do see that the two sides that the parallel lines are connecting are split. All right, so this is a side splitter theorem. And in side splitter, when we learned it on day 9 notes, we realized that we can use the expressions as is. We don't have to separate our triangles. We just have to make sure that we have two pairs of matching pieces. So we like to use our highlighter to do that. And so if I'm looking here in my picture, I see a pair of matching parts already for one of my fractions. And now I just have to find a second pair of matching parts. And I don't quite have, I see that the x and the 5x, but they don't match. X is on the bottom, 5x is the whole side. So I can do a couple things. I can figure out what to put on EC so that the total is 5x, and therefore this, would have to be a 2x down here on the bottom. So that part plus part, 3x plus 2x is 5x. And then I could use the x and the 5x. Or I could do this and find the total here to match the 5x. And you'd have to be careful when you add your expressions together. That would be the x on the bottom plus the x plus 2 on the top. And that would give me x plus x, which is 2x plus 2. So it's up to you which pair you want to use for your second fraction. But I like smaller expressions. And so I'm going to go ahead and use the x on the bottom here with the 2x instead of the 5x and the 2x plus 2. All right, now that I've chosen my two pairs of matching pieces, I can go ahead and set up my proportion, which is my fraction equal to my fraction. So I'm going to start with the x plus 2 and put it over the 3x. And that's going to equal going back to the left-hand side and grabbing the x and putting it over the 2x. All right, now we can go ahead and cross multiply. So 3x times x is a 3x squared equal to my other cross. We just have to be careful that it's 2x times x, which is 2x squared, and then 2x times 2, which is positive 4x. Okay, I'm going to go ahead and, because I have that squared term, I know that I want to keep it positive, so I'm going to bring over my 2x squared this way, and I'll have x squared equal to a 4x. And I know that I have a squared term, which means I'm going to have to factor. Okay, so I'm going to go ahead and bring over my 4x, and so now I have x squared minus 4x equal to 0. And this isn't a trinomial, but it is something called greatest common factor, which you learned in algebra, is that there's an x in common, so we pull it out, and we're left with x minus 4, and we're equal to 0. We're going to come up here, and I'm going to just recopy my last step so you can see what I'm going to do next. Because I'm done factoring, I'm going to do my t-chart. One of my factors is x, and it's going to get set equal to 0. And over here, x minus 4 is going to get set equal to 0, and I'm going to solve this side and get x equals 4. The other side's already solved. All right, and again, we have two answers. However, we know that line segments from our picture, sides of our triangle, cannot have a 0 length or a negative length. And so I'm going to assume that my 0 is going to go away, most likely because DB cannot have a length of 0. Okay, so we're going to reject because DB would equal 0, and we know that that can't happen, so we're going to keep the 4. And all they asked to do was find the value of x, and so I'm going to go ahead and box that up. All right, let's take a look at number 2. We have triangle ABC, and it says that D is on CA and E is on CB, so that DE is parallel to AB. And they're going to tell us that CD is 10, that DA is 2, that DE is 5, and this is a game changer. This is not a side splitter theorem question like the last one, and they want me to find AB. And the reason why it's not a side splitter is because the information that they gave me, the 5 and the x, are not on this side. So no side splitter. Okay, they also didn't tell me that D and E were midpoints to use my midpoint theorem, because if it was midpoints, then AB would have to be 10. Okay, 5 times 2. And so therefore, this is a separate your triangle kind of question. Separate triangles. So I'm going to go ahead and highlight my one triangle so you can see when I redraw it. That triangle right there. I'm going to redraw it over here. And I'm going to go back and relabel the sides on it. One of them is 10 and one of them is 5. Now I'm going to go ahead and look at my second triangle, which is this one. And I'm going to go ahead and redraw that one over here as well. It's a little bit bigger. And on there, I have X on the bottom. And on this side, we got to do a little part plus part equals whole. And we're going to end up with 10 plus 2, which is 12. And now I can go ahead and set up my proportion. I'm going to go ahead and pick 10 and put it over the corresponding side of 12, equal to my 5 over its corresponding side of X. Okay, and do a little cross multiply. That becomes 10 times X, which is 10X, equal to 12 times 5, which is 60. I'm going to go ahead and divide by 10, and X is going to come out to be 6. They want me to find the length of AB, and AB is what I call the X, and therefore AB is going to also equal 6. Okay. All right, let's go ahead and take a look at number 3. It says in triangle ACE, if AB is 12, BC is 16, AD is 15, and DE is 20. Oh, this one's a little reverse question. They're not asking me to solve for anything. They're asking me, are these parallel? And the way we're going to tell is we're going to use the side splitter theorem here. Oops. And if these pieces work in a proportion, then we can go ahead and say that those lines are parallel. All right. So we'll go ahead and test to see if our proportion works. So we'll do 12 over corresponding side of 15, and we're going to see if that's equal to 16 over 20. So we have two ways to test this. We could type it in our calculator, 12 divided by 15, and hit enter. We can also type in 16 divided by 20 and hit enter and see if they come out equal. Or we could go ahead and cross multiply and see if the cross products are equal. Since we've been cross multiplying, we can stick with that, all right? But it doesn't matter whichever way you do it. 12 times 20, when we do this cross, is 240. And we're going to see if it's equal to 15 times 16. If it is, these lines are parallel. If it isn't, then the proportion doesn't work and the lines can't be parallel then, all right? But 15 times 16 is 240. And so we're going to go ahead and say yes, BD is parallel to CE. Okay, all right, I'll see you guys on the back side of notes.